Hello everyone. In this video, I want to give some instructions and get you guys started for our next mission, solving some projectile motion problems. Okay, so we have these tools in our hand, our motion equations we derived for the 2D motion, 2D kinematics. It could be this formula that talks about the change of velocity, acceleration, time. And we came across this formula, the version of that formula along the x direction, and the version of the same formula along the y direction. Same case for these other formulas along the x direction, along the y direction. These will be the tools we are going to use for the next examples. But keep in mind, I discussed this class about this in class as well. This is really, really important. Whenever you talk about, I will discuss some cases later in this video. Whenever you get the acceleration along x, you should only substitute that information in the x formulas. Whenever you have information about v initial along the y direction, v final velocity along the y direction, acceleration along the y direction, this information only goes in any of these y formulas. Never ever substitute x numbers for the y formulas. Okay, same case as here. Again, initial velocity x, the final velocity along x, any of these should go only for these x versions of the formulas. Okay, so now with that, we can move on to talk about some cases, possible cases of these projectile motions. There are two types, I could say, upward motions and downward motion. So if I have a case, again, this guy could be something is tossed vertically upward with an initial velocity v naught. This will go up and comes down along the same direction. Also could be another scenario. You have from the ground level, you are sending something with an initial velocity. This guy will do the projectile motion, the parabolic motion, it will come to the ground level. Also, another possibility, from a rooftop, from the building, you are sending this guy with an angle theta. Again, here to the horizontal angle theta. Again, angle theta, initial velocity v naught. Not only this object will reach the same level as it was projected, this will again do the parabolic motion until it reaches the ground level. Any of these cases, my suggestion for you all to use your vertically upward direction is your positive y direction. Forward along the rightward direction is your x direction. Same as here. X hat, y hat, x hat, y hat. This will make very easy positive, negative signs going in your formulas whenever you are going to apply these formulas. Now, with these coordinate axes, x and y, for any of these cases, we have the gravitational acceleration always vertically downward. G equals 9.81 meters per square second. G vertically downward. Here with the coordinate axis, we are telling that upward direction right here is the positive direction, but the gravitational acceleration is downward. This is where it comes whenever we consider any of these scenarios. Vertically upward is positive, gravitational acceleration is downward. Vertically upward is positive, but the gravitational acceleration is downward. I am saying all the vectors, velocities, positions, accelerations, if they are upward, they should be positive. The reason the gravitational acceleration downward brings that acceleration along the y direction with the negative sign 9.81 meters per square second. This negative sign comes because the gravitational acceleration, any situation right here, it is opposite to where you said vertically upward positive. Okay, now with this, if I get this table right here, whenever you are working on any of these cases, whenever you are trying to fill it out, the information, you will have initial position event 0 starting from the 0. If this is your x hat, if this is your y hat, this will be the origin. So initial position 0, initial position 0. We don't know what these are yet. And acceleration along, and again, if you need meters, the units, acceleration along the x direction, ax, there's nothing, it's a 0. Acceleration along x, 0 meters per square second, just a 0 will work. And acceleration along y direction, this guy will go in right here, negative 9.81 meters per square second. And all the other information, initial x velocity, initial y velocity, final these numbers depends on what number you have here and the angle you have here. Okay, so that is case number 1, upward motions. And if I go down below, downward motions. This could be from a rooftop, you are just dropping something. We initial starting 0, just a drop. Or this could be from the same rooftop, you are projecting something horizontally. We initial is along x direction. And this could be another situation from the rooftop. You are projecting something with an angle. We note with an angle theta, downward projection. In any of these cases, this guy will move downward. This guy will do the downward motion, parabolic shape. Again, this guy will do the same, downward motion. In these scenarios, I would suggest you all pick the coordinate axis. In this situation, we don't even need the x-axis, but again, if you need, there we go. But downward motion, moving down object, I would say pick the y direction downward. Here again, x direction forward, y direction vertically downward. X direction forward, vertically downward direction y hat. Positive direction y downward. This is where again we need to consider. Gravitational acceleration is downward. Gravitational acceleration is downward. Now you all should see. You said positive y direction is downward. Now the gravitational acceleration is in the same direction. Now we can have in our math still x component of the acceleration is 0, nothing along the x direction, but along the y direction, now they are matching. Positive direction, 9.81 meters per square second, positive. whenever you substitute. So if I get the table again, in any of these cases, you can go ahead. If you were to pick right here, this is your origin, X direction right here, Y direction down below. Starting from the origin, you could say 0 initial position, 0 initial position, but acceleration along X, that is 0 meters per square second. Now for this downward Y positive direction match with the gravitational acceleration, you have 9.81 meters per square second. The acceleration is constant. It will stay the same number, meters per square second. So that's the secret, everyone. Whenever we have these examples, again here, it will stay constant. We picked upward direction positive, gravitational acceleration was downward, it was a negative sign. Acceleration will stay constant, negative 9.81 meters per square second. Along the X direction, it will stay a 0 constant. Along the X direction, it will stay 0, a constant. Now, one last thing, everyone. Whenever you have these type of motion problems, you are projecting something with an angle. It will do the projectile motion initial V naught with an angle theta. If you need, you can pick, okay, right here, let me call it the event 1 when it is start. Maximum height, event 2, reach the ground, event 3. Whenever needed, you can consider the whole motion from here to here. Let's say the problem is asking you to find what is the range, that's the displacement along the X direction. You will need to consider, in order to get here, event 1 through event 3. You have to consider the whole motion in order to get the range from here to here. Sometimes it will ask total flight time. How long does the object stay on air? In order to get there, total time, you have to consider this guy, total motion, event 1 starting to end. Sometimes the problem might ask, how much is the maximum height, H max? In here, you will need only to consider half of the motion right here. Event 1 through event 2. So depending on your need, you can consider either the whole motion or the portion of the motion. So we will do many examples in the next class.